Hey guys, today's lesson is on medians and altitudes. First of all, we're going to define a median. It's a line, segment, joining a vertex to the midpoint of the opposite side. Okay, and so what that means is I need to first find my midpoint. So on my bottom side here, my midpoint would be here. So my median would connect my vertex, which is the point on a triangle. So I have 3 vertices. So this is a vertex. So from vertex to midpoint, that's a median. There's 1. On this side, midpoint is about here. Remember, your midpoint is the point in the middle of a line segment. So another median would be from this vertex to that midpoint. And then my last median would be from this midpoint to this vertex. Now, notice all the medians intersect at one point. This is not an accident. I do want to show you this looks like if I have an obtuse triangle. So to show you that they will always do this. So same thing here. The median will connect my vertex to the midpoint here and here. There. And so what this means is just on my sides, this is a midpoint, so this side is going to be congruent to this side. They each get 1 tick mark. This side is congruent to this side. They each get 3. And this one they each get 2. Same goes for this triangle. 1, 1, 2, 2, 3, 3. Now, like I said, it is not an accident that they always intersect at this one point. And that point actually has a name. It is called a centroid. So your centroid is the point where 3 medians of a triangle intersect. So one way to remember it is median sounds kind of like middle. Midpoint is in the middle, so median connects midpoints to vertex. Now, no matter what type of triangle I have, these will always intersect inside the triangle. So if you kind of want to have a side note here, it is always inside the triangle. Okay, so anytime your medians intersect, they will always intersect inside of the triangle. And another side note, which is pretty cool, is where they intersect, so at our centroid here, it splits the line into 2/3 and 1/3. So your centroid splits the median into 1/3 and 2/3. Now, what I mean by that is if I do 1/3 plus 2/3, that makes 3/3, which is 1 whole. So 1/3 of a line plus 2/3 of a line makes the whole line. So let me show you what I mean by that. In this triangle up here, I'll just use this as an example. Let's say that this line right here is 6. Now, if you look, this line is obviously longer than this one. Now, breaking it into sections from the centroid, so my centroid's here in the middle. So the top part of the median to the centroid, and then the bottom part of the median together form one whole median. Now the top is 2/3. Notice it's longer, so you can clearly tell which side's your 2/3 line. So 2/3, I've just identified as 6. So that would make my bottom part 3. 3 plus 6 makes 9. So my whole median has a length of 9. 1/3 of 9 is 3. 2/3 of 9 is 6. So remember in 5th grade when fractions were really important? They're coming back. So this is where you're going to get really familiar with finding 1/3 and 2/3 of numbers. But this works for all your medians. So in this one, the one going diagonal here, the longer side is 2/3, not 2/3 in length, 2/3 of the whole line. And the short side is always 1/3 of the whole line. Works the same over here. This side right here is 2/3 of the line, and this is 1/3. So that'll come in handy when we're doing equations. Just right now, know that your centroid splits the median into 1/3 and 2/3. The next thing we have is an altitude. An altitude, the perpendicular segment from a vertex to its opposite side. So let's kind of review our vocabulary here. Perpendicular is when lines intersect to form a right angle. So we have a perpendicular segment from the vertex to its opposite side. So what that means is if I go from a vertex, your vertex is kind of your corner. So if I go from my vertex to my opposite side, I need to intersect somewhere that it's going to be perpendicular, which means it's going to form a right angle. And this one, this is just kind of an estimation here. I don't have a ruler on me. Maybe right there. That kind of looks like a right angle. If I give it a box, that means it's a right angle. Okay, so an altitude doesn't necessarily split it in the middle. So remember, a median intersected at the midpoint. That is not the true for an altitude. An altitude intersects anywhere that's going to be perpendicular. It means it's going to form a right angle. So if I do from this vertex to this side, and I need a right angle, maybe there. Looks like a right angle. Let's say that. And then my last one, I need to go from this vertex to this side. That looks like a right angle. Notice I don't have a protractor or a ruler or anything like that to get them perfect. But as long as they intersect to form right angles. And you'll know, because in math we give you the little box, or any problem you get is going to have the box on it letting you know it's perpendicular. So they're not going to try and make you guess and figure out if it's perpendicular. You'll know because of the right angles. So that's basically what an altitude is. Just so you know, an altitude does not always intersect in the middle of the triangle, but they do always intersect at one point. Just like a median always intersect at the centroid, your altitudes intersect at the orthocenter. So your orthocenter is where the three altitudes of a triangle intersect. Okay, and just a little side note, this does not have to be inside the triangle. They can intersect outside of your triangle. So you could have an orthocenter that intersects outside of the triangle. That usually happens when you have obtuse triangles. I'll show you some of those in class. That way we can see them. Basically what we have are medians and altitudes. Medians go from vertex to midpoint. Altitudes go from vertex to wherever would make it perpendicular. And then the centroid is the point where the medians intersect. And our orthocenter is the point where the altitudes intersect.